Okay, I'm going to start this lecture by quickly going over pressure basics. In fact, you'll write down most of your notes at the very beginning, then we'll spend some time thinking about how pressure has an effect in our lives. Sometimes we'll think about what's going on at the molecular level, and sometimes we'll just analyze the situation in terms of the different pressures involved. Our goal is to make sure that everyone develops a solid understanding of pressure and atmospheric pressure. Remember, chemistry is a lovely thinking science. So we don't want to just memorize definitions, we want to understand what's going on. Okay, so we're going to start with the pressure of the gas. And it's just, by definition, the force that the gas exerts on the walls of its container. But as you will find, I like to draw. That's kind of how I explain things. And so what I want to do is I want to look at what is going on within that gas sample that causes it to exert a pressure. So I'm going to draw some little molecules of gas, and these could be atoms or molecules, whatever. But this drawing is not at all accurate. I was going to say it's not entirely accurate, but it's really not at all accurate, because in truth the distance between these would be incredibly far apart considering the size of the particles I drew. So really gas molecules are teeny, teeny, tiny, and the space between them is enormous. So we will just use our imaginations and pretend that my drawing is more accurate. Okay, so now we want to think about how these gas particles move. And what they're doing is they're moving in a constant random motion. Okay, so this gas molecule is going zing, 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 whatever. This one hits this and goes over here. This one bounces over here and then bounces over there. But all these particles are continuously moving. And as they collide with the walls of the container, they're exerting a force on the wall every time there's a hit. And what we can do is we can look at pressure in terms of the formula that is used to calculate it. So pressure equals the force over the area. Well, if all of these different gas molecules in here are exerting a force on the wall every time they hit, we can sum up all of those different forces, and then we can take that amount and divide it by the area of the wall. And so that's kind of a way I like to look at pressure, because we can see the two factors that can either increase the pressure or decrease the pressure. So the two factors that affect the pressure. And I did want to point out that we will not do calculations with this formula, but I think it's good to look at qualitatively to think about how different things will affect the pressure. Okay, so just one more thing for this slide. We want to look at the units. And there are a lot of different units for pressure, and you may remember some of them from your previous chemistry classes. So we've got kilopascals, we've got millimeters of mercury, we've got torr, pounds per square inch. So there's many, many different units that are widely used. But for the activities and stuff we are going to be doing, the only one we really need is the atmosphere, which is abbreviated ATM, and so that's the only one I'm going to hold you responsible for. Okay, so that brings us to the atmospheric pressure, which is just the pressure exerted by the gases that make up the atmosphere. Okay, so that's the pressure that we live under every day, because the oxygen and nitrogen and argon in our atmosphere are continually bouncing around, bumping into us, and exerting pressure on us and on everything else on Earth. Our standard value, which is the average value at sea level, is, whoa, I don't know how that happened, 1 atmosphere. I think I picked the wrong pen. So anyway, that is a number that I do expect you to know, just so that you have a reference point. And I'll talk to you in a little bit. Okay, I just want to point out that I rewrote it in case you couldn't read what I had before. So now I'll talk to you in a little bit.